Hello, my name is Jennifer Santoso from University of Tsukuba, Japan. I will talk about our study, which is speech emotion recognition based on attention weight correction using word level confidence measure. As we know, speech emotion recognition, or SER, is a task on identifying the speaker's emotion contained within the utterances. SER enables understanding of human emotions and state of mind, which is an important feedback to enable more natural response in conversation. SER has been widely applied to real life, such as human-robot dialogue system and conversation analysis system. One of the promising methods of SER is to combine acoustic and text feature to decide the emotion class. In recent studies, automatic speech recognition, or ASR result, is used as a text feature due to its practicality in real time. Currently, state-of-the-art methods use BLSTM and self-attention as the feature extractor or classifier. It works well due to BLSTM's ability to capture sequential information and self-attention to focus on important acoustic segments or words by weighing them. However, there are several challenges to realize SER using ASR result as a text information. First, ASR is not robust to emotion, resulting in lots of incorrectly recognized words. These words may end up being focused by self-attention, therefore decreasing the speech emotion recognition's performance. So one conventional method to reduce speech recognition errors in SER was proposed. This method jointly learns SER and ASR end-to-end. And also, to reduce the speech recognition errors, the model firstly used retained ASR model, which are fine-tuned to the emotional datasets. The training is done by simultaneously minimizing SER and ASR loss in multitask learning. This way, ASR model will be able to adapt to emotional data. In overall, the main structure used is the state-of-the-art BLSTM and self-attention mechanism. However, there is one catch. This method requires high computational cost to fine-tune ASR to be robust to emotions. So based on the problem before, we aim to improve SER performance by preventing self-attention from focusing on the incorrectly recognized words. How? We propose to correct the self-attention weighting by using word level confidence measure, or from now on we refer to as CM. So what is CM? It is a measurement on how reliable the ASR result is. It comes in the scale of 0, which is unreliable, to 1, which is reliable. So the example of CM and ASR result is shown in the table. Here, higher CM means ASR is certain with the result, while lower CM would mean a word has probability of being mistaken with another word. So normally, high CM would relate to correctly recognized words, and low CM would correlate to possible incorrect words. However, that does not mean that low CM is always incorrectly recognized. In fact, there are probably many correct word candidates in words with low CM. So, I will now explain the mechanism of the proposed method, which is shown in this image. Here, the tree graph shows text attention before correction, confidence measure, and the text attention after correction, respectively. Here, the word sequence indicate the ASR results of a certain emotional speech. The yellow part are the words that are incorrectly recognized. So before, some of the attention weights peaked at the incorrectly recognized words, which has low confidence measure. This correction is to be applied by lowering the attention weight, making the words less focused. On the other hand, some correct words has low attention weight. However, as they have high CM, the attention weight will be adjusted to be slightly higher. Therefore, this correct word is going to be focused. So, in this study, we investigated 3 methods on applying CM to the text feature extractor. The first one is the early fusion, or known as proposed method 1. Here, CM is combined with the input and used as part of the sequential features. And this will be inputted to BLSTM. The second method is a late fusion, or known as proposed method number 2. Here, instead of combining confidence measure in the beginning as input feature, this method combines confidence measure after the processing of the input features, which is after the BLSTM, therefore reducing the potential CM information loss in earlier stages. And the final method is the attention weight correction, or known as proposed method 3. So here, instead of using confidence as a sequential input to be processed, confidence measure, or CM, is combined with attention weights to directly correct the attention weights. This way, confidence measure has less dependency on textual feature, and therefore, confidence measure has more impact in correcting the attention weights. Moving on with the experiments. In this study, we use IEMOCAP datasets, which contains emotional datasets in English. In total, there are 10 speakers, of which 5 of them are male and 5 of them are female. The length of utterances in IEMOCAP is between 1 to 19 seconds. In this study, we conduct a 4-class experiment in which the class happy is combined with excited. The other classes are sad, neutral, and angry. This experiment is conducted with a 5-fold cross-validation, with each fold corresponds to different sessions and speakers. And moving on, the input feature consists of the acoustic feature and the text feature. The acoustic feature consists of 20-dimension Mel frequency capture coefficients, or MFCC, and 12-dimension constant Q transform, or CQT, and 1-dimension fundamental frequency, or F0. This means that the acoustic feature has a total of 33-dimension features. On the other hand, for the text feature, there are 2 steps. First, we conduct a recognition using a pre-trained model from CalD, trained on LibreSpeech dataset. LibreSpeech dataset is an English dataset with a total duration of approximately 1,000 hours. The result of the recognition is then applied to the dataset in IEMOCAP, and in total it produces a word error rate of 43.5% on the emotional dataset. The recognition results are then encoded using pre-trained BERT, in this case BERT based on case model, which contains 12 layers and 12 heads, resulting in 768 dimension word encoding features. The classifier specification is shown in the table. Both the acoustic feature extractor and text feature extractor uses PLSTM and self-attention, which results are then concatenated and processed to the dense layer, or known as emotional classifier part. Classifier uses Adam as optimizer with a learning rate of 0.0001. The dropout is set to 0.3, and the loss function used is softmax cross entropy. For the training, we run the training epoch up to 100 epoch, with the best epoch taken as the result. So moving on to the experiment results. As we can see on the graph, using the textual information only has higher emotion recognition performance by 11.3 for transcript and 7.6% for text compared to using only speech, which is a great improvement. This way we can say that the text information has a strong influence on the speech emotion recognition results. Next, we try to combine the speech and text information in emotion recognition. By combining speech and text information, the speech emotion recognition performance improves by quite a lot of margin here. From speech, it increased by 14.1% for transcript and 9.9% for the ASR result. From using only text, the combination of speech and text information yields a gain of 2.8% for transcript and 2.3% for ASR results. Now we compare the speech and text, the method using speech and text as in ASR result, with our proposed methods. So among the proposed method 3 provides the best results. This is possibly due to the information loss in proposed method 1 and proposed method 2, requiring more data to perform optimally. In any case, the 3 proposed methods all outperforms the method using speech and ASR results. And now we compare our proposed method, which is proposed method 3, with the previous studies. Here we can see that our proposed method, which is the attention rate correction, outperformed the performance from the other methods in the previous studies. So to conclude, we propose an SER method that uses ASR result as text information in word level CM. We investigated the combination of a self-attention mechanism and the word level CM in reducing the effects of speech recognition errors on the ASR result, used as the text feature in SER on the IEMOCAP dataset. Also, among the approaches proposed to apply CM, using CM as attention rate correction yields the best performance. Thank you for listening.